Hi, welcome to this training on accessibility and the web. This is lesson 1 in the course on accessibility and web development. In this lesson, we'll learn about the goals and motivations behind accessibility best practices, how the web is different for users who access it with assistive technologies, and a few basic principles to give you a head start when you're coding accessible applications. Accessible web interfaces provide all users with the ability to access, consume, and interact with digital media while maintaining content, message, and purpose. To be accessible, an application must allow a person with impairment in vision, hearing, motion, or cognition, or difficulties with language, age, or technological limitations, to accomplish the same goals as a person without any of these difficulties. The main goal of accessibility is to give all users, regardless of their mode of interaction or any impairment or difficulty, an experience that is equivalent to that of a user without any impairment or difficulty. Now we'll look at a few sets of rules that influence the web development process. Section 508, an amendment to the United States Workforce Rehabilitation Act of 1973, includes the federal laws, regulations, policies, and standards that govern accessibility in information technology. It requires all federal departments and agencies, including public universities, to make the technology they buy, develop, maintain, or use accessible to individuals with disabilities, giving them the same access as individuals without disabilities. If making a technology accessible would cause an undue burden on the department or agency, Section 508 still requires them to develop an alternative means of delivering the information or data provided by that technology. Although Section 508 doesn't include any information on how to meet the requirements it sets forth, other groups have established best practices for creating accessible applications and websites that comply with Section 508. The World Wide Web Consortium, or W3C, provides a comprehensive set of guidelines for writing accessible code. These guidelines are called the Web Content Accessibility Guidelines, or WCAG 2.0. They state that all web content must be perceivable, meaning that users can sense them; operable, meaning that users can interact with them as intended; understandable, meaning that the interface and its information make logical sense; and robust, meaning that it behaves similarly for all types of users. Unlike Section 508, these guidelines do not carry the full force of law at this time, although they are scheduled to become law in 2012. Section 508 will refer to WCAG 2.0 because it links directly to actual samples of code and includes very practical information on how to write accessible code. The state of Illinois has additional laws that govern accessible IT. The Illinois Information Technology Accessibility Act, or IITAA, includes more specific and rigorous guidelines for websites, information systems, and information technologies with specific definitions of each. They also define the types of disabilities that need to be considered, stating that web content must be available to people with limited vision or blindness, hearing loss or deafness, limited speech or no speech, and limited reach or no reach or sense of touch. IITAA is closely synchronized with pending updates to Section 508 and WCAG 2.0, so adhering to IITAA standards will make compliance with the other two easier. Accessibility is a usability concern. When websites are coded accessibly, it's easier for users with different abilities that are using different devices to have equivalent experiences. Standard, valid, robust code creates a more predictable experience for everyone, including mobile technology users and users of assistive technologies. As a developer, you are making decisions about how people will be able to access your code, so ultimately, it is your responsibility to make your code accessible. However, project managers and accessibility consultants can and should support developers to make accessibility an important part of the development cycle. Remember, you are responsible for making your applications usable by individuals with or without disabilities. If your application cannot provide equivalent functionality for all users with disabilities, consider alternative means for those users to complete tasks and receive information, and ask the project manager to plan for those. Adhere to state and federal laws and consider W3C best practices to create accessible applications. To review this section, the main goal of accessibility best practices is to provide an equivalent experience for all users. Section 508 are the federal laws that govern IT accessibility. WCAG 2.0 are the best practices guidelines proposed by the web community. They include specific examples of code and how to meet Section 508 requirements. IITAA are the state laws that govern IT accessibility, and they include references to WCAG 2.0 best practices as a way to fulfill legal requirements. If you have questions about how to write actual accessible code, look to WCAG 2.0 or IITAA. If you have questions about where a requirement comes from for accessible code, refer to Section 508 or IITAA. Remember, accessibility is a usability concern. It's more like a specific type of usability. The web works differently for users with disabilities than it does for non-disabled users. Although all users can have an equivalent experience, there are certain things to consider about a disabled user's web experience when coding for accessibility. We'll discuss modes of interaction, linearization in reading order, and colorization. Writing code that renders as expected in every browser represents a significant part of development time, but cross-browser testing is an important part of the development process. In addition to considering users' browser choices, developers coding for accessibility should consider the multiple ways that disabled users access web pages. Non-disabled users of the web have a largely visual experience. Computer monitors display a website's graphics, text, and multimedia content, and a mouse allows a visual user to navigate. However, some users may experience a web page via a screen reader, which is a tool that turns content into audio content, or via a Braille keyboard, which renders text as Braille, so that a non-sighted user can perceive it. Screen readers also navigate web pages with keyboards or other pointing devices, but not mice, since using a mouse requires vision. In addition to non-sighted users, many power users prefer keyboard navigation to mouse navigation, so they'll appreciate your consideration as well. Users with low mobility may use different kinds of pointing devices, such as puffers, track sticks, or eye tracking. For visual users, monitors display a website's graphics, text, and multimedia content simultaneously, and users can quickly scan the page visually to find the content they want. Users of assistive technologies, however, can only experience one element of a web page at a time. When a screen reader interacts with a web page, it is linearized, meaning that all the elements of the page are put into a single line and read to the user one at a time. The position of the elements in this line is determined by the structure of the HTML code itself. To be accessible, HTML code should match the visual flow of the page, providing a logical reading order. In this example, the reading order of the page doesn't match the visual flow. Users become frustrated since the main navigation is one of the last elements that they encounter. By moving the code for the main navigation to the beginning of the document and restructuring other parts of the code, users will experience a more logical flow of information. The challenges presented by linearization in reading order, such as this one, are easily dealt with by following W3C best practices for standard valid markup. Another element to consider is how users experience color. Not all monitors display color the same way, and not all people see colors the same way. Some users may have different kinds of color blindness, which may prevent some color schemes from being perceivable. For example, users with protanomaly, or red weakness, may have a limited ability to perceive red. If a website has a black and red color scheme, an individual with this type of color blindness would not perceive the difference between red and black as easily, which may effectively make some page elements invisible. Users with deuteranomaly, or green weakness, have the same experience with green. Protanomaly affects 1 out of every 100 males, and deuteranomaly affects 5 out of every 100 males. The best way to overcome these issues is to use high contrast color schemes and to avoid communicating important information with color alone. Again, there are many different types of color blindness. Learn more about how color blindness works by visiting colorvisiontesting.com. As a developer, it's your job to make all functionality available via keyboard. Make sure you use valid standard markup to make the web experience more predictable and equivalent for all users. Structure your code in the same way that it is presented visually, and know that this will be the reading order for users of assistive technologies. Consider multiple modes of interaction and test for them in the same way that you do cross-browser testing when possible. Don't rely solely on visuals or color to convey meaning. Provide alternative means such as alt text or description and summary elements. Use high contrast color schemes that will be perceivable by all users and keep common types of color blindness in mind when choosing color schemes. Remember, users have different ways of interacting with the web page besides monitors and mice, so support different modes of interaction in the same way you support different browsers. For users of many assistive technologies, pages are linearized and experienced one element at a time. Check the elements linearized in a logical order. Reading order of pages is determined by the structure of the HTML code, so make sure that the structure of your code matches the visual layout of the interface. All people perceive color differently, and some people may not be able to perceive certain colors at all. Use high contrast color schemes to make different elements easier to detect. There are 4 basic principles to consider when coding for accessibility. We've discussed what accessibility means and how the web is different for users with disabilities, but considering these principles will help you keep their goals and perspectives in mind when you're creating interfaces. Purpose. An accessible web interface will have a well-defined and clearly indicated purpose. It will have meaningful page titles at the beginning of the code that will give the user a hint about what they can find or do on the page. It will help them know if this is the page they're looking for, and whether or not they can accomplish what they intend with that page. Structure. An accessible web interface will communicate structure to the user in a clear, understandable way. It will tell the user where things are on the page and give them context for interacting with them. Use heading tags such as H1, H2, and H3, and use them in a logical order instead of simply styling a piece of text to look like a heading by increasing the font and making it bold. Where they are, and where they can go from here. It will make a path of navigation easily understandable and will tell the users whether or not they can come back if they need to. Interaction. When users reach an accessible interface, they'll be able to successfully complete the task they came to do on that page. For example, if the interface is a form, users will be able to interact with and manipulate all form fields and will be able to successfully submit the form regardless of the mode of interaction. This concludes Lesson 1, Accessibility in the Web. Complete the Lesson 1 practice and example exercises from the Illinois Compass 2G classroom and work through the discussion exercises with your fellow trainees or your group. After you've completed the submitted assignments, take the quiz in Lesson 1 and submit it to complete the lesson.